Hello, welcome to my presentation. This presentation was prepared for iSight's 2020 conference. So the topic that I would like to discuss today is on the characterization of Andrassy bentonite as grounding enhancement material. So before we begin, I would like to talk about some of the basics on electrical grounding. There are a few aspects that we need to understand before you can actually dive into what I'm going to discuss later on. So lightning strikes affect building structures by producing high electrical field on the surface and around high-rise structures. Currently, several methods have been proposed to improve the lightning performance of transmission line, although various approaches and safety measures have been considered. The soil type is still the primary factor to determine the grounding resistance. The main problem depends entirely on the soil type, as different soil possess different behavior and characteristics, which includes soil resistivity, ionization, and the level of corrosive environment. A good grounding enhancement material should provide low earth resistance over a long period with little variation of the resistivity value. So the maximum grounding electrode resistance of large electrical substation and commercial and industrial substation should be approximately 1 ohm and 2 to 5 ohm. In order to achieve this, alternative grounding material are often used to minimize the problem. So in recent years, there are various studies have been reported on the use of bentonite as grounding enhancement material, or in short, GEM, in electrical earthing as found in the literature. According to research by Lim et al., bentonite is suitable as backfill material in decreasing and maintaining the low grounding resistance of electrodes for a long time due to its high water absorption and water retention tendency. So what is bentonite? So bentonite is a naturally occurring clay mostly derived from volcanic formation, mainly consists of montmorillonite minerals. Bentonite are classified based on their major exchangeable cations such as sodium bentonite, calcium bentonite, or other mixed type bentonite. There are three main bentonite processing plants in Malaysia, which is located one each in Perak, in Johor, Selangor. However, unfortunately, all the raw bentonite is imported. Malaysia has imported 73,269 tons of bentonite, mostly from other countries such as India, China, the US, Australia, and Germany. So due to this unique characteristic of bentonite, having high water retention capabilities, the electrical resistivity of bentonite are usually very low. So when talking about electrical resistivity of bentonite, one of the main criteria of selecting a good gem is the electrical resistivity behavior, and bentonite actually suited very well with this requirement. However, in most studies, the resistivity of bentonites are reported as a single value or a two value under wet or dry conditions. The change in the resistivity is governed by the change in the water content. So when the water content is high, so the resistivity are usually the invert of water content, and it is usually very low. So the more water you have in the bentonite sample, the lower is the resistivity. Similarly, the water content also influences the state in which the bentonite can occur. So depending on the water content, bentonite can be in the form of solid, semi-solid, plastic, or even in liquid state. No studies to date have shown the evolution of resistivity under these states. So it is not known whether the resistivity behavior is only two values under wet and dry condition, or is it actually follows the limit state of the material. So depending on the water content, bentonite can be in the form of solid, semi-solid, plastic, or liquid. As been mentioned before, no studies have been conducted to show the evolution of resistivity under these states. So this specific study actually covers this aspect, and thus the resistivity is expected to change with different state, which in turn would affect the performance of the bentonite as grounding material. Therefore, the objective of this study are to determine the effect of plasticity characteristics on the electrical resistivity of Andrassy bentonite, and secondly, to investigate the suitability of Andrassy bentonite as grounding enhancement material. So the bentonite used in this study are collected from Sabah volcanic deposit. The next step is to establish the geotechnical properties and establishing the plasticity characteristic, and lastly, measuring the resistivity. These are the geotechnical properties of the soil or of the bentonite that we use in the study. And based on the plasticity characteristic, that we can see that this is the dry state, this is the semi-solid state, this is the plastic state, and this is the liquid state. So based on the resistivity analysis, it has shown clearly that the resistivity behavior actually follows closely the state of the bentonite. So it seems that the result that we achieve here is somewhat comparable with the one reported in the literature. So the resistive behavior is directly affected by the water content and the limit state of bentonite use. More water, the greater is the reduction in the resistivity values. However, beyond liquid limit value, the resistivity value did not further reduce. The result of Andrassy bentonite is comparable with other reference bentonite reported in the literature. Thus, it is expected that Andrassy bentonite may be considered as gem for grounding application. Thank you very much for your kind attention. Hope to see you in other session.